Good morning students. In this class we are going to discuss a new chapter, theory of indices. So indices means it is the plural form of index. It is the plural form of index. Index it's also called power or exponent. So index of the number, it says that how many times we use the number in a multiplication. For example, consider, so multiply 2 with itself 7 times. 2 into 2 into 7 times. 7. So this can be written as 2 to the power of 7. Here 7 is called the index, power or exponent. Here this says that, so how many times we use 2 here in this multiplication? We use 2 here 7 times. So similarly consider 10 into 10 is equal to 10 square. This can be written as 10 square. 10 square is equal to 100. Here 2 to the power of 7 is equal to 128. Here index 2 says that we use 10 2 times. Similarly consider 10 3 times in this multiplication. So this can be written as 10 to the power of 3. This is equal to 1000. Okay. Here the index or power of the number 10 is 3. It says that we use in this multiplication we use 10 3 times. So in general consider a into a into a up to n times. Total m times. This can be written as a to the power of n. A to the power of n. Here 7 is called the exponent, power or index of the number. Here 2 is called the index of the number. Index or power or exponent. 2 is called the base. 2 is called here base. 7 is called exponent or power or index. Here also 2 is called index, 10 is called base. Here 3 is called exponent or power or index, 10 is called base. So in general here n is called the index, a is called the base. Here a is non-zero real number, n is any positive integer. Okay. Now let us discuss laws of exponents or laws of indices. First law of exponents. First law of exponent is, consider a is any non-zero real number and m and n are positive integers, then a to the power of m into a to the power of n is equal to a to the power of m plus n. This is called first law of exponents or first law of indices. So now let us prove. Here first consider LHS. Consider LHS. LHS is equal to here a to the power of m into a to the power of n. So a to the power of m is a into a into a, total up to a, total how many times? M times. M times. Next into a to the power of n means a into up to a, total n times, etc. up to a, total n times. So this is equal to here a into a, total how many times? M plus n times. For example, consider 2 to the power of 3 into 2 to the power of 4. So here 2 to the power of 3 means 2 3 times. 2 into 2 into 2 into 2 to the power of 4 means 2 4 times. So 2 into 2 into 2 into 2 is equal to, so 2 how many times? 1, 2, 3, 4, 5, 6, 7. So 2 to the power of 7. So 3 plus 4 is equal to 7. Similarly, here A, m times, here A into A up to A, n times total, A into A into A up to A total, m plus n times. So this can be written as A into A into A up to m plus n times means A to the power of m plus n is equal to RHS. Is equal to RHS. Therefore, A to the power of m into A to the power of n is equal to A to the power of n. So, if base is same, then add the powers. So, similarly, so consider 3 terms. A to the power of m into A to the power of n into A to the power of p. Into A to the power of p. Here also base is same. So, add the powers. So, this can be written as A to the power of m plus n plus p. So, in general, A to the power of m into A to the power of n into A to the power of p into A to the power of k, etc. is equal to A to the power of m plus n plus p plus k plus etc. Okay. So, next let us derive second law of exponents. Second law of exponents is A to the power of m divided by A to the power of n is equal to A to the power of m minus n if m is greater than n. So, A to the power of n divided by A to the power of n is also equal to 1 by A to the power of n minus n when if m is less than n, if n is less than n. So, proof. First, consider here m is greater than n. M is greater than n. Now, consider left hand side. A to the power of m divided by A to the power of n. So, A to the power of m can be written as A into A up to A. So many times? M times. M times divided by A to the power of n means A n times. So, A n times. Here observe, here given m is greater than n, m is greater than n. So, here A get cancelled. So, A how many times? N times get cancelled, remaining A into A in numerator. A up to A how many times? So, consider for some examples. Consider 2 to the power of 7 divided by 2 to the power of 4. M is here, this is m, this is n. M is greater than m. So, this can be written as 2 7 times. 1, 2, 3, 4, 5, 6, 7. 7 times. Next, divided by 2 to the power of 4 can be written as 2 into 2 into 2 into 2. 4 times. Here 2 get cancelled. 2 get cancelled. 2 by 2 get cancelled. So, remaining 2 3 times in numerator. 2 into 2 into 2. So, how many times? 3 times. Means 7 minus 4. 7 minus 4 is 3. So m minus n times in numerator. So how many terms are remaining? M minus 7 minus 4 is 3. So here in general, here m is greater than n. So remaining m minus n times. N minus m times. So this can be written as a up to m minus n times means a to the power of m minus n. A to the power of m minus n. Okay. Next, consider second condition. M is less than n. Consider here m is less than n. So m is less than n. So consider here 4, here 7. Okay. So consider a to the power of m divided by a to the power of n. A to the power of m divided by a to the power of n. So a to the power of m can be done as a into a up to a m times divided by here a to the power of n means a into a up to a, how many times? N times. So here a, so remaining term. So consider this example. Here m is less than n. So 2 to the power of 4 can be written as 2 into 4 times divided by 2 to the power of 7 means 2 7 times. 3, 4, 5, 6, 7 times. So 2 get cancelled, 2 get cancelled, here 2, this 2 get cancelled. So remaining in remaining terms. So in denominator, so numerator 1, in denominator we have 2 into 2. How many times? 3 times means 7 minus 4 is 3. So this is m, this is n. So 7 minus 4 means n minus m times. So 3 times. 3 times means 7 minus 4 times. So here in general 1 by a into a up to a, how many times? N minus m times. N minus n times. So this can be written as 1 by a into a. Total n minus m times means this can be written as a to the power of n minus m. So therefore a to the power of m divided by a to the power of n is equal to 1 divided by a to the power of n minus m when if m is less than n. This is called second law of exponents. Okay, next third law of exponents. Next, third law of exponents. Next law is called third law of exponents is a to the power of m whole to the power of n is equal to a to the power of m into n. Okay, proof. This is called third law of exponents. Proof. So consider a to the power of m whole to the power of n. So this can be written as a to the power of n whole to the power of n means, suppose if we consider 2 to the power of 7 means 2 into how many times? 7 times. So here a to the power of m how many times? N times. So a to the power of m into a to the power of m into a to the power of m up to a to the power of m. How many times? n times. N times. So here a to the power of m means a m times. A into a into a. How many times? M times. A into up to a m times. Into next here also a m times. A into up to a. How many times? N times. So total into n times. Next a into a into a into a into a up to a. How many times? So consider some example. So suppose first consider here two terms. First consider only two terms, a to the power of m into a to the power of m. So here apply first law of exponent. First law of exponents is a to the power of m into a to the power of n is equal to a to the power of m plus n. If base is same, so add the powers. So here a to the power of m into a to the power of m is a to the power of m plus m. M plus m is 2m. If we consider two terms, a to the power of m into a to the power of m, a to the power of m plus m. This equal to a to the power of 2m, m plus m, 2m. Suppose if we consider three terms, a to the power of m into a to the power of m into a to the power of m, m plus m plus m, m plus m plus m. This equal to m plus m is 3m. So here we use 3 times. So a to the power of 3m. So similarly here we use a to the power of m into a to the power of m. How many times? N times. So n into m times or m into n times. N into m or this can be written as m into n times. So a into up to a. How many times? M n times. This can be written as a to the power of m into n. A to the power of m into n. Therefore, a to the power of m, o to the power of n is equal to a to the power of m into n. Okay. Next, fourth law. Okay, next. Fourth law of exponents is a into b whole to the power of m is equal to a to the power of m into b to the power of m. So split the power to each term, a to the power of m into b to the power of n. So fifth law of exponents is a by b whole to the power of m. This can be written as a to the power of m divided by b to the power of m. Okay. Next. Okay. Next, some important notes. First point. So consider a. A is any non-zero real number. Then a to the power of 0 is always equal to 1. So any number with power 0 is always equal to 1. For example, consider 2 to the power of 0 is equal to 1. 3 to the power of 0 is equal to 1. So minus 5. Consider any real number. Minus 5 to the power of 0 is also equal to 1. Consider 1 by 3. 1 by 3 to the power of 0 is also equal to 1. Okay. Next, second point. A to the power of minus m. Here m is positive integer, then this can be written as 1 by a to the power of plus m. For example, 2 to the power of minus 4. So this can be written as 1 by, take into denominator, it becomes 2 to the power of plus 4. For example, consider 5 to the power of minus 7. This can be written as 1 by 5 to the power of plus 7. Okay, next, third point. qth root of a to the power of p. Qth root of a to the power of p is equal to a to the power of p by q. For example, so here square root of 5, this can be written as 5 to the power, square root can be written as 1 by 2. Okay. Consider cube root of 2, this can be written as 2 to the power of 1 by 3. Okay. Fifth root of 7, this can be written as fifth root, this can be written as 7 to the power of 1 by 5. Similarly, qth root can be written as a to the qth root of a to the power of p. Here, write a to the power of p as it is. Qth root can be written as 1 by q. So now apply third law of exponent. Third law of exponent is a to the power of m whole to the power of n is m into n. So this is p into 1 by q is equal to p by q. So a to the power of p by q. Okay. Now let us discuss some problems. First mean simplify the following. Simplify the following. First question. 2 to the power of 3 into 2 to the power of 4. Okay. So now simplify. So this can be written as basis same, so add the power. So 3 plus 4, 2 to the power of 7. So 2 to the power of 7 means 2 7 times. 4, 5, 6, 7 times. So 2 to the power of 7 is equal to 128. Therefore, 2 to the power of 3 into 2 to the power of 4 is equal to 128. So next problem. Second one. 2 cube divided by 2 to the power of 4. 2 3 times. Here 4 times. 2 get cancelled. So remaining 1 by 2 or 2 to the power of minus 1. Okay, next problem. Third one. 2 into 3 whole to the power of 4. Here either apply formula. So fourth law of exponent is of the form AB O to the power of m. AB O to the power of m means split power to each term. 2 to the power of 4 into 3 to the power of 4. So 2 to the power of 4 is 16 into 3 to the power of 4 is 81. So 16 into 81 is equal to 1296. Or one more method. So 2 into 3 6 whole to the power of 4 means 6 4 times. 6 into 6 into 6 into 6 is also equal to 1296. Okay. So next problem. 2 square whole to the power of 5. 2 square whole to the power of 5. So here this can be written as, here apply third law of exponents. A to the power of m whole to the power of, there are two powers, multiply the powers. 2 into 5. So 2 into 5 10. 2 to the power of 10 is 1024. Or one more method. 2 square is 4 whole to the power of 5. So means 4 5 times. 4 into 4 into 4 into 4 into 4 is equal to, so 4 5 times is also equal to 1024. 4. Okay. Next problem. Five whole to the power of 5 to the power of 0 plus 5 square whole to the power of 0. Okay, simplify here. Write 5 as it is. Okay. 5 to the power of 0 is 1. 5 to the power of 0 is 1 plus 5, either right 2, there are 2 powers, multiply the powers, 2 into 0, 0. So 5 to the power of 1 means 5 plus 5 to the power of 0 is 1. 5 plus 1, 6. So value of this problem is 6. Okay, next question. Nine by 4 whole to the power of minus 3 by 2. 9 by 4 whole to the power of minus 3 by 2. Here observe, we have negative value in the power, so make it into positive. So it would take this term into denominator, it becomes positive. 9 by 4 minus 3 by 2 becomes plus 3 by 2. Now split the power to each term. 1 by 9 to the power of 3 by 2 divided by 4 to the power of 3 by 2. 9 to the power of 3 by 2 divided by 4 to the power of 3 by 2. So here apply fifth law of exponents. Next, take this term, whole term to numerator, then it becomes 1. Take this term into numerator, it becomes into 4 to the power of 3 by 2 divided by 9 to the power of 3 by 2. 4 to the power of 3 by 2 divided by 9 to the power of 3 by 2. So 1 into 4 to the power of 3 by 2 divided by 9 to the power of 3 by 2 is 4 to the power of 3 by 2 divided by 9 to the power of 3 by 2. Here 4 can be written as 2 square whole to the power of 3 by 2 divided by 9 can be written as 3 square whole to the power of 3 by 2. Here 2 into 3 by 2, 2 get cancelled, 3. So apply third law of exponent, a to the power of m, o to the power of m. There are 2 powers, multiply the powers. So 3 power 2 into 3 by 2, 2 get cancelled, 3. So 2 cube is 8. So 3 cube is 27. So 8 by 27. Next problem, 5x cube divided by y whole to the power of 2. Simplify, you split the power to each term. 5x cube whole square divided by 5 square, sorry, y square. Yeah, so split the power to each term. 5 square x cube whole square divided by, write y square as it is. So 5 square is 25 into x cube whole to the power of 2. So here there are 2 powers, multiply the powers. 3 into 2, 6. So it is x to the power of 6 divided by y square. So 25 x to the power of 6 divided by y square. Okay. We will continue in next class. Thank you.